Hello everyone. So on this video I'm going to go over an example on what is an application of like the normal distributions, finding probabilities, finding the value of a random variable, finding the value of a probability or of a z-score, of a standard deviation. On this example, I'm going to show you what we can do whenever they are giving us a specific situation, a real life situation, right? Where we can go ahead and use normal distribution. For this one, we have that the average salary for all U.S. teachers is $47,750. Then it says to assume that the distribution for this is normal and the standard deviation is $5,680. That means that for every teacher, right, the amount that they or the salary that they make, right, for every year, it's going to be getting away from the mean by like $5,680. So that's going to be kind of like the difference or the average difference. Now it says find the probability that a randomly selected teacher earns, and then question 8 between $35,000 and $45,000 a year. Now, this says, right, that what we want to do is basically this is a normal distribution. However, we haven't normalized the values. What do I mean by that? We are still working with random variables. So basically what this is saying is that your random variable x is 35,000 and the other random variable x is 45,000. What we want to do is work with actually a standard normal distribution. Where again the mean is 0 and the standard deviation is 0. Equals 1, I'm sorry. Now, this doesn't mean that we have to convert the mean from 47,750 to 0 and the standard deviation from $5,680 to 1. No, that's not what it means. Basically, what we can do to normalize this complete situation or this problem is to find the z values. So in order to normalize, I don't know why I thought it was blue. Never mind. So to normalize, so standard, we want to find the z-scores. Now, how do we do that? Well, we're going to use that formula that I showed you on the slide, the PowerPoint slide for lesson 6.2. Now, for that one, I showed you that it's like kind of like a way of finding the random values. However, that same formula can be used to find standard deviations, z-scores, and again, random variables. So what that rule says, or that formula is, we have x equals z times standard deviation plus mu, which is the mean, right? If we solve for z, and you can actually find this formula on slide 7 from the PowerPoint, z equals x minus the mean over the standard deviation. So we're basically solving for z. Now this is what we're going to be using to normalize the problem. So what we're going to do is we're going to have z equals 35,000 minus 47,750 over the standard deviation, which is 5,680, right? So the 40, again, I mentioned this, the 47,000 is the mean, and the 5,680 is the standard deviation. And then for the other value, we have 45,000 minus 47,750 over $5,680. Okay, so let's go ahead and find the first one. So for the first one, we have 37,000 minus 47,750, and that is negative 12,750 over 5,680, and that is equal to negative 2.24. So this is the first z value. Now the second z value, it's 45,000 minus 47,750, which is negative 2,750, again over 5,680, 5,680, and that is negative 0.48. So this is our second z value. Now from here, what we're going to do is we're going to go to basically our graph. So we have our bell graph. We know that the mean is 0. And then we have 1, 2, 3. Then we have negative 1, negative 2, negative 3. Well, our two z values are negative 2.24, let's say it's this, and then negative 0.48, which let's say it's somewhere here. So negative 0.48. And what we want to do is find that area in between. So to find that area in between, we're going to have to use the table, right, from the textbook. So if I go to the table on the textbook, I'm going to find that the area under negative 0.48 it's going to be negative 0.48, 1, 2, 3, 4, 5, 6, 7, 8. It's 0.3156, 0.3156. And then the area under negative 2.24 will be 0.0125. So the area under negative 2.24 is 0.0125. So again, like this whole thing, if I go ahead and do like the whole area for negative 0.08, I'll say it's the red, so it's all of this, right? So all of that, I don't really have enough space, so I'll do it down here, is 0.3156. I'll use orange for the other one. So for this area, which is this space right here, it's 0.0125. Now we want to find the in between, the blue, so what we're going to do is we're going to subtract those two areas. So the area or probability is 0.3156 minus 0.0125. And if I go ahead and do that, 0.3156 minus 0.0125 equals 0.3031. And that is the probability and the area, the blue one, between those two values. Okay. So that is one example. Let's go ahead and do another one. So this is part A. Let's go ahead and try part B. So for B, we want to find the probability of a teacher who earns more than $40,000 a year. So again, this is actually our x term, right? So this is our x value. We want to normalize this. So step 1 is to normalize. Again, by standard. What this means is finding z equals x minus the mean over the standard deviation. In this case, it'll be 40,000 minus 47,750 over the 5,680. So when we do that, we get negative 7,750 over 5,680, which is going to be negative 1.36. So that means that our bell graph is going to look something like this. So again, the mean is 0. We have negative 1 here, negative 2. Our z value is at negative 1.36. Let's say it's here. I did not put a negative right there. This should be a negative. So it is z equals negative 1.36. Now they're asking for more than, right? So we need to find the area to the right. So more than means more than, oh, what is that? Let me rewrite that. More than means to the right of the z value. Now let's remember that when we're looking for the area to the right, we want to subtract, right, whatever area we find on the table from 1, right? Let's remember that this whole area is 1. And the table, it's giving us the area to the left. So to find the area to the right, we have to subtract 1 minus whatever area it's on the table. So we're going to have 1 minus, and then if we go to negative 1.36 on the table, we get 0.869. So 0.0869, and we're going to subtract those two values. 869, which is 0.9131, and that will be our probability. Okay, so that's how we can find or normalize, like a situation that can be given to us, and we can find the probabilities from that situation as we find our z-scores, and then we find the area under the curve for those specific values.